Good morning, guys. Today we are going to be working on graphing linear inequalities. The good thing about this is it's almost identical to graphing slope-intercept form and graphing linear equations. The only difference is we have a couple different things we need to do with the line, and we will need to shade a little bit. So for these first four problems right here, we will be working on graphing the parent function y equals x. And we're going to start off with y is greater than or equal to x. So if we kind of think of this as slope-intercept form as y equals x plus 0, you can't see that very well. Let me try a different black marker. Y equals x and plus 0, and then be the same as y equals 1 over 1x plus 0. We know that our y-intercept will be at 0. We'll make a dot at 0, and then our slope is up 1 over 1. It's actually cut right through the middle, cut it half diagonally, just like that right there. So there is our line for y is greater than or equal to x. Difference now is for this one, it's going to be one difference. If it was y equals x, this is our solution. All the x's and all the y's are our solutions. But for this, it says y is greater than or equal to x. So we want all the times when our y value is greater than our x value. So if I pick a point right here, our y is 4, our x is 1, the y value is greater than the x value. Well, maybe I pick a point over here. My y value is 4 again, my x value would be -6. It's still greater. Maybe I go down here. My y value would be -3, my x value would be -5, so my y value is still greater than my x value. So when we have a greater than sign, all we have to do is graph the line like we usually do in slope-intercept form, and then we're just going to shade above it. Everything above it is also a solution. This is all a solution to the inequality y is greater than or equal to x. Maybe we pick a point on the line like right here, 3, 3. The y value is 3, the x value is 3. Is 3 greater than or equal to 3? Yeah, it's equal to 3. So that is a way we can check our solution. Let's pick a point that we didn't shade. Say I pick this point right here. It would be 3, -2. Is our y value greater than our x value? No. And that's why it's not part of our solution. That's why it's not shaded in, because it's not true. So we want all the times that our y value is greater than our x value. Let's move on to the next one, which is y is greater than x. This one is similar, besides it actually has a difference. Here, everything on the line is part of our solution, because like I said right here, 3, 3, 3 is greater than or equal to 3. But if I got rid of this line, is 3 greater than 3? No. So it wouldn't be part of our solution set. So whenever we have a greater than sign or a less than sign, we will have a dashed line like this. And I like to equate it to when we graph inequalities on a number line. If we have a less than or greater than sign, we have a filled in circle. And if we have a less than or greater than, or I should say if you're a less than or equal to or greater than or equal to sign, our circle is filled in when we graph it. And when we have just a less than or just a greater than, we leave our circle hollow. Well, same thing here. When we have an equal to sign, we have our line filled in, and when we have no equal to sign, our line is dashed. We will still shade above. Just like that. On the bottom two, it's the exact same, except you'll see that it is the less than sign. So my graph will still go through my origin with a slope of 1. But this time, because my inequality says it's less than, I am going to shade below. And once again, let's pick a point on here and check it. If I pick this point right here, that point would be +6, +3. That's my x. Is 6 greater than the y? Is 6 greater than 3? Yeah, so we know it's true. If I pick a point here, this would be -6, +5. Is -6 greater than +5? No, and that's why it's not in the shaded in part. So the big difference here is when you have slope-intercept form, the only things that are a solution that can make, the only x's and y's that can make this true lie on the actual line. But when we substitute the equal sign in for less than or greater than sign, that means everything on that line possibly and everything below it or above it could also be true. On the next one, it's going to be exactly like, it's going to be a combination of these two. There is no equal to sign, so we're going to have a dashed line. But we're going to shade below it. Just like that. So big difference between slip-intercept form, or big difference in graphing linear inequalities, I should say it that way, that's more of a true statement, is that it should be shaded above when it's greater than or equal to, or greater than, and below if it's the less than symbols. And if there is no equal to sign, it's dashed. If there is an equal to sign, it's hollow. The only other ones I want to talk about is the kind of the oddballs, the ones where we have no slope or no y-intercept, like y equals 3. I would put a dot at my 3 on my y-axis. That's going to be a horizontal line. It's going to be filled in because I have an equal to sign. And because it's greater, I know we said above, so we're going to shade above. That one's not the hard one. So there's that one. On x is less than or equal to 3, here is my 3 on my x-axis. So it's going to have a line going straight up and down. And think of a number line now, because we can't shade above or below it because it's a horizontal or it's a vertical line. But think of a number line. If it's less than, it's going to the left. If it's greater than, it's going to the right. So I need to shade this to the left. And when you guys do your homework, it doesn't have to be like a completely shaded in block. Don't spend your time shading it in and just coloring in. I mean, this is good enough here. As long as I can legibly read if it's above or below, that's good enough. But that's kind of the intro into graphing linear inequalities. Please watch the second video because I'm going to do 4 more examples that are a little bit more difficult. But that's the basics. Watch the other video.